As humans, our ability to have powerful perception and to reason from what we feel, see, and hear makes us so special. Now we're bringing that to computers. We talk about AI if a computer has the capabilities which are usually associated with human intelligence. As T-Systems, we believe that now AI has the maturity to get into production. Scalable, reliable, and connected. I am René Phan, chapter lead for Artificial Intelligence and Machine Learning, and today I want to show you how to reap benefits out of AI. In the industrial context, AI systems perform quality controls, predicting machine failures, doing inventory tracking, or even autonomous logistics. It is common sense that AI comes with enormous business values. Frontier economics estimates about 40% increase in labor productivity. For manufacturing, that means overall equipment efficiency, machine availability, and even servitized business models. But there is a gap between ambition and reality. Everybody thinks about AI. 58% are testing AI and just 12% are using AI actively. So today, we talk about to optimize the way we get AI into production. Let's start with how AI can help your organization. So quality is a critical issue for all production processes, like pressing, welding, or even assembling. Automated quality processes are expensive in terms of processes, in terms of process costs, and equipment. Based on sensors and visual information, AI can early recognize indicators on quality issues directly within the process. This means to prevent failures from happening and increases the overall equipment efficiency. Because it's in real time, it also improves the throughput. In logistics, we also have challenges. So there are fast processes with heterogeneous partners and a huge amount of different logistics objects. So having control about processes, about the inventory, is important for logistics management, as well as identifying efficiency potentials. With the use of camera systems and AI, we can analyze transition areas and inventory and even their state. Displaying this in a digital twin makes easy access to information. So that helps logistics management as well as enables it to have alarm systems for sensitive areas. So where's the catch? Why does AI not scale today? The International Data Corporation estimates that more of half the AI projects are not realized in a productive scenario. So as T-Systems, we are supporting different companies in AI projects, and we are seeing the following challenges. So first, there is a problem with the integration of business processes, IT systems, and data sources. And that also means to enable business units very early in the process to benefit from the AI application development. The second one is a clear path from a proof of concept to a productive environment with a productive AI application. And the third main part is reliability, availability, and also the costs of production, so the total cost of ownership. And it's important to notice that in most of the cases, AI models are not the problem. Let's dive deeper into those challenges in our customer discussions. So welcome Jörg as our sales expert.
Hi René.
Hi Jörg. So you're our sales expert for AI and big data. You talk to a lot of customers and you know the projects very well. Based on our experience, let's discuss the AI customer journey.
So we typically start with a common workshop. And this is workshop, we bring in together different stakeholders. The first thing is the business department of our customers. The second thing is the IT department and the AI expertise from our side. So after having discussed the business goals and the relevant use cases to achieve those goals, we talk about data, because data is the fundament for AI projects. So when we ask our customers typically, is data available? Basically, all customers says, yes, data is available to start with. So if we take then a closer look, we recognize that we talk about different data. So for example, the business experts talk about maintenance plans. The IT experts, they talk about log files from IT systems. And when we talk about data for AI projects, we talk typically about raw data, sensor data. So the first goal is to have a common understanding about what we are talking about. And the second thing is how to get the data, how to ingest the data in an AI environment. So let's take some examples. With a consumer good manufacturer, we surveyed 10 different robots. Only those 10 robots, among others within the whole production line, they already produced 14,000 different sensor values. So quite huge amount of data and complex because of the amount of different sensor values. So the first thing is how to capture the data, how to extract the data from the machinery controllers, and how to make the data available. Let's take another example. With an automotive manufacturer, we are extracting data from automotive, so from mobile assets, which also produce a huge amount of data. Across the whole fleet, we are talking about 2 petabytes of data at the moment. So the challenge is that those locally ingested data from the cars are not easy to transmit to central cloud. So basically what's needed is we need to do a pre-processing on the edge, next to the data, next to the car. As we see, also the data ingest is quite complex. How do we solve typically such challenges with our customers?
Yeah, you mentioned a good point. So you already said we have to start with the use case, and with the use case where the business units can see the business value in it. And if we define a business case, then we have to start small. So we can use historical data, for example, to start and to create a feasibility whether we can create the business value the business unit thinks they have. But then in order to do so, we need to create a mutual understanding with the business unit together to identify which indicators lead to which problems and how we can resolve this using machine learning and AI. So we have to start the journey together, and we have to also explore the data together. And this is very important to also meet the business goals. And a lot of projects fails with those things today. And in the end, you cannot stop by using historical data. You also need sometimes more data sources. So we also provide ST systems with sensors. We also provide with cameras and also edge hardware to really get real data from the project, from the machines in a real productive environment. And in order to do so, we are also serving with edge devices. And as you said, there might be scenarios where you cannot transmit the whole data because of its volume. So we can also support to bring the code to the data, to aggregate on an edge device, and then send back just the relevant information to a development platform. And this is how we can support the customer by starting with the data availability, and also with the interfaces you need to create the availability.
Okay, thank you. Okay, so after having the first step done, the data ingest and making sure that data is available, we start with the proof of concept. We start with the modeling. So we do the modeling, the training of the algorithms, and the validation with the customer. So the results I see most times is that you not only achieve a positive result, so the probability to really have a successful proof of concept is quite high, but also we get some benefits which weren't targeted before. So for example, with a consumer good manufacturer, we recognized that 10,000 of the 14,000 sensor values are basically not changing at all. So basically there is no urgent need to do a monitoring of those data. So nevertheless, the proof of concepts are not always put into production. So only a little percentage of the successful proofs of concepts are really then put into operation, into a productive IT and business environment. Why is that?
That is a typical challenge with AI projects. So in the first step, what you need to identify the real relevant data is to, of course, get access to the data, as we told before. And to get access, you need to be sufficient on for example, the security aspects you mentioned. And as T-Systems, we're in the Deutsche Telekom company, and we have a privacy and security assessment for all our services. So there is a sufficient proof that we are secure in our systems we build. And in terms of getting into productive environments, you also need some kind of a strategy to roll out. So if you first, in the first step, just test in a really restricted area where you're doing just the AI development, just the proof of concept, and then you are thinking about rollout, you face a lot of things like not just the interfaces, but also monitoring, like logging and how to do operations for the systems. And there are plenty more of those things, like also edge hardware and computing capabilities. And as T-Systems, we are also helping with that one, and we are trying to create a continuous integration or a continuous deployment even for AI projects. So that means that we can deploy in the project, and the business units which are working with the systems and getting to know the systems, they are learning that the systems improve over time. They are learning the improvement in the models and the AI services. So they also have a higher trust because they can work together with us on the systems. And this makes this prevents from failure in AI projects.
Okay, so this helps a lot in terms of deployment, in terms of bringing systems into production, also managing a cost for deployment. So if customers are now doing rollouts, it's also a question of reliability. It's also in terms of cost for the whole system, also for the operation part. So when we take a look at one of our customers, Deutsche Bahn, where we do the Prognoseautomat, where we are calculating billions of different models each night and where we do updates on the system, it's a question how to make such services reliable, so really keep the system online. And the next thing is how to basically update the models, how to incorporate changes in the framework, in the local situations, also in the models. How can we improve, or how can customers improve their reliability and the total cost of ownership of such systems?
Yeah, totally. We already discussed that we need a clear path from proof of concept to the productive environment. So as you already said, with Deutsche Bahn, we are doing like thousands and millions of predictions every day for the departure for trains, for example. So this means that we also need to ensure the reliability over time. So if certain changes in environmental factors are done, we have to retrain models. And this is like a closed loop. You always have to retrain models, and then you have to deploy, and you have to test for, of course, so that your models are reliable. And having standardized components for those pipelines, for those automated processes is really, really important to also decrease the costs. Because if you do it every time individually, if you develop it every time individually, you will have a cost for development of platforms, of having also the application, the operations for that, and on the first, second, and third level, of course. So having all those things, thinking about all those things, we are facing a lot of costs. So one thing is standardization and automation from the beginning and to have the right tools at hand. And the other thing is also to reuse a platform you already built for one project and use it also for other projects as well. So having a standardized framework approach. So thank you, Jörg, for being here.
Thank you very much, René.
And thank you for the customer insights.
Thank you.
What if there was a way to reduce the risk of failure in AI projects? The AI Solution Factory from T-Systems enables AI application creation from development to an integrated application in a cloud or edge environment. Our focus is to be ready to scale from day one, to have end-to-end integration from interfaces to software to hardware and even DevOps. And this to a cost efficiency through automation, standardization, and a multi-purpose environment. This also needs to be reliable, available, and security. And we do it by design using our processes. And this is how it works. We standardize the environment for development of AI services using our deep learning factory. There, we have automated pipelines which enables flexibility in AI frameworks as well as automation from training to testing to deployment. And once you set up the pipeline, you have a full automation till productive environments. With no code, you can set up new experiments and evaluate by predefined performance indicators based on your business needs. We work together with NVIDIA to scale industrial AI applications worldwide. So this also involves to get business units early in the process and to integrate an easy-to-use labeling tool which enables business units to label their own data by themselves because they know it best. In our AI application suite, you are able to run AI services to scale out multiple use cases on a single framework. This reduces the complexity and cost of operations. And for seamless integration, we have multiple connectors to execution systems like SAP and Salesforce. Finally, it is important to support business units with flexible configurations of the processes. So we are separating the AI services from the decision logic, which makes it easier to configure what to do after a detection happens. All in all, it is important to improve cost efficiency. That is why we focus on automation as well as standardization for interfaces as well as operations. As T-Systems, we always focus on systems which are working integrated. Thus, we support in all layers: edge devices, cameras, platforms, applications, and even connectivity. The AI Solution Factory can be deployed to all hyperscalers and even to edge or on-premise hardware. This means our system is independent from vendors or cloud providers. There is no lock-in effect. Using our telecom and standard privacy and security assessment, we are building our systems secure and reliable by design. The key, as we discussed, is to get started. Start small, grow big. Fail fast, and scale even faster. Let's rewire a new problem that requires more innovative approaches. Let's talk. You have a POC done already and want to scale it up? We can help with that, of course. We would like to conclude by saying that this is a journey and not a destination. AI is a tool for productive excellence and not an end in itself. So let's take the journey together. We invite you for our upcoming webinar on 27th of April on this topic. The longer we sit on the fence, the longer it is going to take us to scale up and reap the benefits out of AI in production. Here are a few ways to accelerate your journey. So let's build it together. You bring the use case, we bring the framework, and we build it together. Pilot your AI journey with one of the use cases we have already built, and we work together to tailor use cases for your needs. And if you have any questions, please feel free to contact me. Thank you.
How do you keep the momentum you gained by introducing cloud?
Enterprises that want to remain competitive and successful need to efficiently combine IT and OT. And we believe edge computing will play a key role in this next phase of digitalization.
Join our discussion at Hannover Messe to learn about the question, is edge the new cloud for factories?